Hey everyone, welcome back to Geeky Course. Today we are going to solve a classic coding problem that every programmer should know, and the problem name is two-sum problem. We will explore both naive and optimized methods to solve it. But before we start, make sure to hit that subscribe button and ring the bell so you never miss an update from our channel. And stick around till the end for a bonus tip on optimizing your code even further. So let's check for the problem. All right, let's start by understanding the problem. We have been given an array of integers and a target sum. We need to find two numbers in the array that add up to the target. For example, if our array is 2, 7, 11, 15 and target is given as 9. The two numbers that add up to 9 are 2 and 7 and we will return their index that is 0, 1. And the same example is given as our array is 3 2 4 and target has been given as 6, and then the numbers that add up to 6 are 2 4 and their indexes are 1 2. And the same goes with the third example, that is our array contains two values 3 3 and target has been given as 6, then it returns 0 1. First, let's tackle the naive method. This approach involves checking each pair of numbers in the array to see if they add up to the target, and it's straightforward but not very efficient. So what we can do to we will do is that we will loop through each element in the array with a variable I, and inside this loop we will use another loop with a variable j that starts from I plus 1 to the end of the array. And for each pair I comma j, check if sum of array I and array j equals to the target. If it does, then we will return the indexes I and j. So let's implement this method. So first of all, we will define the length of the array, that is nums, and then we will loop through the array, that is first loop I in range n, and then we will start in another loop inside the first one, and that will be like in the range of I plus 1 comma n, and then we will check if nums I plus nums j equal to our target. Then we will return an array of I comma j. Otherwise we will return none. Now let's check if this solution is being accepted by LeetCode or not. As we can see here that our code has passed all the test cases. That is case 1, where example array is 2 7 11 and 15, and case 2, that is uh, array is 3 2 4, and test case 3 contains two values, that is 3 3, and the target has been given 6, and output should be 0 1, and expected is also 0 1. So that's it for the naive method, and let's submit it and check for the performance of this solution. Now for the performance of this code is that it beats only 23.90% of users with Python. As you can see, this method uses a nested loop resulting in a time complexity of O(n) square. That is why it has beaten only 23.90% of users, and this can be quite slow for large arrays. Now let's move on to the optimized method. This approach uses a hash map to keep track of the numbers we have seen so far and their indices. So the step-by-step process is, first of all we will create an empty hash map, and then we will loop through the array with a variable I, and for each element, that is nums I, we will calculate the complement as target minus num size and check if the complement is already in the hash map. If it is, then we will return the indices of the complement and the current element. And if not, we will add the current element and its indices to the hash map. So let's implement this solution. So first of all, we will create a hash map equal to empty hash map, and for I comma num in enumerate nums complement equal to target minus num, and if complement is already available in our hash map, that is num underscore map, then we will return the indices of the complement and the current element, that is num map of the complement comma I. Otherwise we will return like we will add the current element to the hash map, and that is num map of num equal to I. And otherwise we will return if our sum does not exist in our array, then we will return none. Now let's check if the solution is accepted by this lead code or not. As we can see here that our solution has been accepted, and it has passed all three test cases. And now this method significantly improves efficiency with the time complexity of on, because we only look through the array only once and perform constant time lookups and insertions in the hash map. So that is, and now we will check for the performance of this code on lead code, and check how does it compare with other users. So as we can see here that our performance of the code has improved significantly. Now earlier it was only beating 23.90% of users, now it beats 47.90% of users. So two different approaches to solving the two sum problem. The naive method is simple but slow, while the optimized method is faster and more efficient. Which method do you prefer? Let us know in the comments below. And thanks for watching. If you found this video helpful, please give it a thumbs up and share it with your friends. Do not forget to subscribe and click the notification bell so you won't miss any update of our videos. And as promised, here is a quick bonus tip. Always consider the trade-offs between the time complexity and space complexity when choosing your algorithm. So happy coding, and see you in next video.